Good afternoon. This is Team One with our final case study exploring the pilot shortage that the Air Force is currently facing. I'm Christian. I got Dan and Jake here with me to explain our process. Starting off, we'll go with the bottom line up front, moving over to the problem statement, and then we'll walk you through the first steps of our analysis, moving through into the deterministic and stochastic analyses, and finishing off with the recommendation.
Okay, so here's our bottom line up front. We would like to present to you the steps that we took to get to our option to decrease the time in the pilot pipeline while increasing manning at training bases to speed up the process of producing more pilots. We did this to take care of the issue that there is an extreme pilot shortage in the Air Force. We needed a cost-effective and reliable and plausible solution for this issue. So some assumptions that we needed to make for this project include: we assumed that there were 2,000 total pilots, a 2,000 total pilot shortage. We also assumed that the Air Force had the means to increase the number of instructor pilots as well as the number of training bases. Furthermore, we assumed that just because we decreased the time in the pilot pipeline, that would not actually decrease the level of the training of our Air Force pilots. So here's our decision hierarchy. We started with a couple questions. For example, we needed to ask ourselves if indeed new systems needed to be invented. If not, what systems needed to be improved? And lastly, something we needed to understand was what was the largest available budget for this project.
So looking at our candidates, we came up with two viable solutions out of our five alternatives. The first one is to increase pay and flight time to encourage retired pilots to come back to the Air Force while also increasing recruitment of new pilots. Our second one was decreasing the time in the pipeline while also increasing the manning at the bases so that we could pump pilots through faster so we can recruit more pilots and increase the pilot force. The three goals that guided our decision analysis towards a solution were increasing the pilot force, maximizing pilot retention, and increasing the training capacity. These three aspects were we thought were the most effective in combating the problem that we face, and we got our value measures from these. Pay and flight time had the highest score, so it had the best value, but we ultimately decided on decreasing the time spent in the pipeline because of its lower cost.
So here you can see our deterministic analysis. We came up with two overarching functions. The first one was manning, and then it had the objectives to increase the pilot force and maximize retention of the current pilot force. In between those, for increasing the pilot force, our measures were hiring more pilots or hiring old retired pilots, which has been a thought that has gone through in current day. And maximizing retention, that's increasing flight hours for both tankers and fighters, decreasing alternate jobs, and increasing pay. The second function was training, where we had the two objectives to increase the capacity and decrease the time in the pipeline. And those measures were increasing bases, increasing IPs, and decreasing time in the pipeline. Below that, you can see all of our different measurements that we talked to our decision makers, that you guys decided how much you wanted to weight each one. And below that were our objective functions for each of those different measures. As you can see below, each of those five courses of action, we measured each different thing and pretty much came up with these values you can see in the bottom right. So the first course of action had 26.42, second course of action 11.45, so on and so forth. You can see our best two were the course of action 4 and 5. Course of action 4 had an incredibly high value in comparison to everything else, but it also had a $13.6 billion cost. And our next one had a 35, which was just over half of course of action 4, which is $1.3 billion. In the top left, you can see our cost analysis. We took different pays based off today's values and used those to come up with a average cost for each of these course of actions. So the next slide here, we're talking about our sensitivity analysis, and we did this on each of the different measures, and we came up with basically how these measures would change if we weighted them differently. Of course, we stuck with the weights you gave to us, but here here's kind of how they change overall. This one specifically is talking about if we decrease alternate jobs or not and how we weight those differently. So here was our stochastic analysis. We put most of our uncertainty in number of new pilots because no matter what, as long as you change like how many pilots want to come into the Air Force changes over time, and so each of these is kind of just some kind of uncertainty based off the course of action that we take. So you can see over in our stochastic value versus cost how much the uncertainty affects these values. So course of action 4 does have very little uncertainty that it takes into account and is going to be pretty stable in its value. Course of action 5 itself is a little bit more unstable with its value, but of course its price is still incredibly decreased from course of action 4.
Our final recommendation is course of action 5, just because of the price value comparison with course of action 4, even though it has a much higher value than course of action 5. Or 5's cost is much more attractive.
Of course, if the budget is high enough, we would recommend course of action 4 because it's a lot more effective. Any questions?